welcome to video lesson 5.7, where we are going to continue practicing grafting on the coordinate grid, but in addition, we're going to be talking about reflections today. Go ahead and fill in your table of contents with page 62, titled Reflections. You're going to need that purple note sheet that I gave you in class. The only thing you have to do for this one, it's not complicated like the other one, is to just fold it like a book so that it'll fit into your notebook. Okay, so to start off, I have some pictures to talk about what the idea of a reflection is in general, and then we'll move into the math. So obviously, when you look into the mirror, you see your reflection. Similarly, I have a couple pictures with a mirror. The mirror line, or the point where your image is reflected, is vertical. So you can see this pug looking at himself, and you have a vertical mirror. I like this one a lot because you can literally see that center point where the cat on the left is mirroring the cat on the right. So its reflection is the same. There's an eye lined up, there's the nose lined up, and the other eye and the ear. You can see very clearly that the center line where the image is reflected from is vertical. So I thought that was a good picture to show what a reflection would be. Reflections also happen in nature, but this time the reflection is not vertical, it's horizontal. So you have this pond or this body of water that is acting as the mirror. So you can see all of the bushes and trees and mountains reflected on the bottom. One last picture. We have, this is another example of a horizontal mirror line where you have this leopard walking, and you can definitely see that the reflection, you could almost fold this picture in half at that line, and these two animals would line up perfectly. And that's the important thing to remember about a reflection. So now let's move into the math behind why or how this works. So here we have a picture of two triangles similar to the cat and dog. The mirror line is this vertical y-axis. So now we're on the coordinate plane, and we have two lines similar to the mirror and similar to the water. This one is being reflected like it's looking in a mirror. So that's on the y. So this point of the triangle is now reflected in the opposite direction. And let's look at the change in these ordered pairs. This is -2, 3. And then this one over here is 2, 3. Let's look at this one. The tip or the top of this triangle is -10, 0. Over here, its reflection is 10, 0. And we have -3, -2, and then it changes to 3, -2. So hopefully you'll notice that something changed with all of these points when it was reflected around the y-axis. Let's look at another one. This one's a little bit clearer. So we have, again, two triangles being reflected, and they're being reflected around the y-axis, meaning the center where you could fold that graph in half and have the two triangles line up is around or on the y-axis. So this is called the mirror line or the center line. And then you have this triangle, and it's labeled A, B, and C. And then you have this triangle. This is the reflected triangle because it has A and a little dash, a 1, a B1, and a C1. So those are the same points, just reflected. That's why you have that little 1. Almost like an exponent, but it's just a little hash mark or 1. So now let's look at just point C. So point C originally was 5, 1. Once it was reflected around the y-axis, it became -5, 1. So point C is 5 units to the right of the y-axis, and point C1 is 5 units to the left of the y-axis. So I'll get a couple more. Here's another slightly blurry version, but it is, again, the red triangle is reflected like it's looking in a pond, or you have a horizontal, here's the x and y, mirror line, or a center line, where you could fold this and have them line up perfectly. And again, if you're noticing for this one, you should start to notice that this point of the triangle, 6, 5, now becomes 6, -5. Similarly, this was -2, 2, and now it's -2, -2. So again, this is a picture that is starting up here and then being reflected around or reflected through the x-axis. And then -1, 7 becomes -1, -7. Last one, a little bit clearer. So we have, again, two triangles being reflected as if they were looking at a pond or a lake. So here's the horizon or the water, and we have point B starting out at 2, 4, and then it's changed to 2, -4. So it is 4 units above the x-axis, and now it is 4 units below the x-axis. Notice the thing that didn't change is where it is on the x-axis. So that's going to be important to realize. Now let's take some notes. So hopefully you've noticed that a reflection, based on all the pictures we've seen, is a point or picture that is the same distance from the central line, which is like that mirror line. It could be the y-axis or the x-axis. So it's the same distance from that line, but in the opposite direction. So moving down in your notes, we're going to talk about what literally happens to the points. Now we're going to deal with 2, 3. I know you have a grid to the right. We're going to actually graph 2, 3, and we're just going to call it point P. Again, you do have to fix your arrows, and let's label y and x-axis. All right, we're set. So we have a point 2, 3, and we have the directions that it's going to be reflected around the x-axis, meaning we're going to go through the x-axis and go past it. And we're going to cross the x-axis. And in order to figure out what ordered pairs the new point would be, P1, we would have to take the opposite of the y coordinate. We have the x, y. The 3 is the y coordinate, so our new point would be 2, -3. So 2, -3 would be P1. Notice those 2 points are at the same x value, 2. That didn't change. The only thing that changed is where it was lining up according to the y-axis. Even though it's being reflected around the x, the only thing that changes is the y. Now let's take this same point and we're going to reflect it around or through the y-axis. If you want to reflect it around the y-axis, you're going to take the 2 now and take the opposite of that. So opposite of +2 is -2. So now we're, instead of going to be 2 places to the right of the y-axis, we're going to be 2 places to the left. And I'm just going to call this one P2. If you were to fold that paper along the y-axis, these 2 points would line up. If you were to take this picture and fold it on the x-axis, these 2 points would line up. So here's the biggest thing you have to remember when you're dealing with reflections. When you're reflecting around the x-axis, you're going through the x-axis, so you're going to leave the x value alone and just take the opposite of the y. When you're reflecting around the y-axis, you're going to leave the y coordinate alone, and the only thing you're going to change is the x. You're going to take the opposite of that x value. So reflecting around the x, change the y. Reflecting around the y, change the x. So now I'm over on the right-hand side of our notes for the rest of the video. You should have the x and the y axis labeled. I have my P, my P1, and my P2 there from the other side, but now I'm going to go on the bottom and actually practice reflecting with 4 points that we have here, A, B, C, and D. So point A is 5, 5, and it's telling us to reflect it around the x-axis. Since we're going around the x-axis, the x value doesn't change. So I'm going to put that in first, and I know I need to take the opposite of the y, and that will become -5. Now I'm going to graph both of them and make sure that it looks like it'll be reflected. So here is 5, 5. I'm going to label that A, and then I'm still going to go to that same 5, but now instead of going up 5, I'm going down 5. So now here is a 1. And if you have some color, it is helpful to show that distance. Here's for up, and here's the same down. You wanted to do that just so that you can see that this distance is the same. That's a good visual. Moving on to point B, we have B as -2, 4. We're still reflecting around the x. So the x value doesn't change. So it's going to stay -2. And the y value, we're going to take the opposite of that, which is -4. Now let's make sure the picture works. The original point is -2, 4. So here we have B. We're going to be reflecting it across the x, which instead of going up 4, we're going down 4. So we have -2, -4 for B1. And again, here's 1, 2, 3, 4, and then 1, 2, 3, 4 in the opposite direction. This x-axis is the mirror line, or the center. Great. Now it's time to reflect around the y. Point C, we have -1, -3. Because we're reflecting around the y, the -3 stays the same, and the -1 changes to its opposite, which is +1. So let's graph these 2 points, C1 and C. So let's start with C, -1, -3. We have C being 1 unit away from the y-axis, so it should be 1 unit away, but in the opposite direction for C1. So 1, -3 is going to be 1 unit to the right versus 1 unit to the left. So we have this to the center line, and then the 1 more hop in the opposite direction. So we have C and C1 with 1 point left. Point D is 4, -1. Reflecting around the y means we leave the y alone. So -1 is going to stay a -1. The only thing that changes is the x, and we have to take the opposite of that, which is -4. Now let's graph D and D1. So we have 4, -1, which is right here. We'll label that D. This time we have 4 units until we get to the y-axis. Now we need to have D1 4 units in the opposite direction. So -4, -1 will take us 4 units in the opposite direction and drop us down to the same point. Here's D1, and we have 1, 2, 3, 4 to get to our center line as well. So we are going to practice again graphing points, but dealing with reflections tomorrow. There is a project in store for you related to this, so it's really important that we understand reflections. And the biggest thing to remember, if you're reflecting around the x-axis, you're going to change the y to its opposite. If you're reflecting around the y-axis, you're going to change the x value to its opposite. Look forward to seeing you tomorrow. Have a great rest of your day. Bye.